Today we will be folding what is called a triangular octahedra, very much like the one I'm spinning in my hand. Beautiful geometric solid. We will start with a rectangular piece of paper. The dimensions of the rectangle can be determined in several different ways. The length of the rectangle will be twice the size of one side of the equilateral triangle that forms one face of the octahedra. I've highlighted the triangle in yellow to see, and again the length is twice the size. The width will be twice the height of the same equilateral triangle. To show the exact folding diagonals, I have divided the rectangle into 8 smaller rectangles. As you can see here, I highlighted that in yellow. There is 1, 2, 3, 4, 5, 6, 7, 8 of those smaller rectangles. The first fold is the diagonal of the smaller rectangle, like so. You do that on one side, you do it on the other. The second fold is along the diagonal of the larger rectangle, as shown here. Again, diagonal. You do that on this side, and you do it on the other side. You will end up with a parallelogram. One side has the packets, another side is a flat piece of paper. We will take this parallelogram and fold it along the lines of the 4 equilateral triangles that form it. 1 equilateral, 2 equilateral, 3, 4 equilateral triangles. 1, 2, 3, 4. Fold like so. Like so. The folds have to be as accurate as possible for you to end up with the right shape. The other fold will have to take place right alongside the middle triangle, like so. So you have basically a figure that can fold in this fashion. Away, and remember again, the packets are on the outside, the opposite side which you fold. You will need 4 pieces folded just like this one. 1, 2, 3, 4. Notice that they are all facing in the exact same way. You cannot have a piece going in the opposite direction. And the packets are always on this side. You fold always away from the packet. First way to connect it is like so. Notice that you pivot around here to make the first fold. It's a little tricky because it's a little loose, but with a little patience you can get it done. There is 2 of the pieces that fold, and if you notice, they fold in this fashion. Basically they form a square pyramid. That's one side. Now we will continue by following the packets. This will go into there. Again. Always on the outside. Keep the flap on the outside. Right there. As you can see, we have 3 other pieces that make it. Eventually it's going to look something like that. The final piece falls right into the missing packet. You open it up, open up. These pieces go on the outside, like such. Fold each piece into its corresponding packet. Like so. Remember, all the flaps go on the outside. Tighten it up a little bit. And as you can see, now we have here a triangular octahedra. Triangular octahedra means each side is a triangle and has 8 equal sides. That is one of Plato's Platonic 5. That's one. This one I will not show you because it's very easy to fold. It takes 2 pieces. One that you guys are really going to like is the icosahedra, which takes 20 pieces. And of course, each piece is a rectangle. And this one, which will really be a challenge, which is the dodecahedra, which 12 sides, each of them being a pentagon. I'm sure you'll be waiting for the instructions how to make this one.